Hi, everybody. So today you're learning about ocean acidification, and that should be no surprise to you because we've already been talking about it. Our learning targets for today are for you to analyze some data. So this data might be data that you will use in your interview that you need to do and turn in by Friday, unless you're a senior, of course, then you don't. And we're going to learn about where the atmospheric carbon dioxide data comes from and then how it affects pH. Okay. So remember, you do have an interview, which is your last assignment for this trimester. It's due on the 18th, which is this coming Friday. And if you're a senior, you don't have to do it. When you're ready to complete this assignment, go to the assignment, and it has all these details in it. All right. So today we're going to start out with looking at some data that looks a lot like your assignment from last Friday. Last Thursday, and where you have this red jagged line that kind of moves up as we go through time. And you were asked to interpret this on Thursday. Hopefully you were able to see that on the far left axis, vertical axis, it has carbon dioxide, and that's in parts per million. And as time passes, we see that the carbon dioxide increases. It's important to know that this data comes from atmospheric carbon dioxide levels. The next graph you were asked to interpret looked like this. This blue graph has a similar increasing trend, except this is measuring dissolved carbon dioxide in oceanic water. So again, it would be in parts per million. You look at the axis, and over time you can see that the dissolved carbon dioxide has increased. Finally, you looked at this graph, and this graph you used the right hand vertical axis where we're reading pH over time, and you should note that this trend is that the pH decreases as time passes. So we see, generally speaking, as carbon dioxide levels increase in our atmosphere, they also increase in our oceans, and corresponding with that same timeline, we see a decrease in the pH. So right now, I'd like you to pause and write an I learned statement about these graphs, just to summarize the trends that you see or heard. Okay, so now you should be coming back from writing your I learned statement, and you should be able to talk about what acidification means. So let's talk a little bit more about that. If we combined all three of these data sets together, you can see that there's definitely a definitive correlation between the atmospheric carbon dioxide increasing, and then similarly at almost the exact same rate, the dissolved carbon dioxide is increasing. But the pH is decreasing. So what's making that happen? Well, first, let's talk about where we get this data from. Atmospheric data comes from Mauna Loa, which is in Hawaii, and these are pictures of the actual site that they do the data collection at, and they're doing constant data collection at this site, and it's funded through the Scripps Institute. There's a couple links on here, so if you're interested in maybe checking out the work they do, then you can follow those links. It's pretty cool. But the oceanic carbon dioxide levels obviously can't come from high up in the mountaintops in Hawaii, and rather they come from in the ocean, where research vessels go out and gather water samples from a particular depth, and then they do a comparative analysis over time. So this is just a research vessel, and it's showing one of these kind of contraptions that they will lower down into the ocean. This next slide is showing when they're pulling it up, and you can see the little canisters that are around the side. Each one of those gets filled with a sample, and then they can use it to analyze the dissolved carbon dioxide. Another way that they collect data in the ocean is through buoys, and we have buoys that are set up right here off the shore of Washington in La Push. And La Push, Washington's real-time data are linked to the actual data near La Push verbiage that's on this page. So if you want to go check out what's going on right here in Washington and what the trend is off our shores, then you can go there. There's lots of buoys set up around the world. They're an inexpensive way for us to actually gather data. In the data that we looked at over time last Wednesday, the carbon dioxide values were kind of shown historically as well. And so if you didn't know where we get that data from, we use ice cores, and they kind of drill down deep into the ice, and then they use the bubbles that are trapped in it, and they can relate that back to the concentration of carbon dioxide that was present at that particular time that the ice was frozen. It's very interesting work. All right, so we were talking about carbon dioxide in the atmosphere, and lots of people will say, well, that's not a problem at all. So I thought, so you have an idea of how much carbon dioxide we're releasing. I'd throw some numbers or data in there. So it's estimated that between 1994 and 2007, about 34 billion metric tons of carbon were absorbed into the ocean. And so if you're thinking about how much that might be, that's about 2.6 billion metric tons per year. Okay, so this picture of a pickup truck over here on the left-hand side, that's a 1-ton pickup truck. So you'd need 2.6 billion of those pickup trucks to be tossed into the ocean to show about the same amount in mass of how much carbon is being absorbed by the ocean each year. 2.6 billion. That's quite a bit. And so if we look at what's going on over time, the rate at which we're putting the carbon dioxide into the atmosphere, the trend here is that it's increasing over time. And that's not surprising. We also see that it's increasing over time in the oceans as well. All right, so this video, I'd like you to go ahead and watch. So pause this and watch the video using the slides and the hyperlink. And you can watch the whole thing, but at least watch the first minute and a half. And that's because it reviews kind of in action all the data collection that we just talked about and brings up some good points. Okay, so now let's talk about the connection between the atmospheric carbon dioxide and the dissolved carbon dioxide and this pH, what's going on with the pH changes. To do this, let's think about the formula for water. You already know that, right? And the formula for carbon dioxide. You know that too. So if you've combined those two things, H2O and CO2, what you come up with is the formula for carbonic acid, which is H2CO3. So it's really a synthesis reaction where the water molecule and the carbon dioxide molecule combined. So in this next slide, you can see carbonic acid. This is the formula up here, H2CO3, and then this is what the actual molecule shape looks like. You can see how it's just CO2 and then H2O, but it's kind of reformed in a different molecule. And carbonic acid acts differently than carbon dioxide and also acts differently than water. And that's because it's an acid. So what we see when water and carbon dioxide mix together and chemically react, they form carbonic acid. But then almost immediately in our oceans, because of the conditions in the ocean currently, that first hydrogen will dissociate. So in this first reaction, it dissociates where one hydrogen is released and bicarbonate is formed. And right now, that's what's happening in our oceans in the majority of the molecules of carbonic acid that are made. One hydrogen will be released and one hydrogen stays behind to form bicarbonate. But if it does go to completion, where both of the hydrogens are released, then there's a carbonate ion that's left behind. So you can talk, or you can listen to this video on ocean acidification. It gives you good graphics. It talks about the combination of carbon dioxide and water, the formation of carbonic acid, and then when or which of those particular products are favored. So go ahead and pause this and go watch the Bozeman video. All right, so coming back from watching the Bozeman video, you should have noticed that he showed this graph in the video. And what's really interesting about this is if you look at the pH that we are currently at, this blue zone, what's favored in the blue zone is the hydrogen carbonate or bicarbonate. And hydrogen carbonate makes it so seashells cannot be formed the same way they would be if there was just carbonate available, or calcium carbonate, really, that's available for the shells. And so it puts pressure on especially small shellfish when they're just forming their, like the nucleus of their seashells. They can't form the right way, and so they become brittle. Okay, so this graph right here, we can talk about it more. It's kind of complicated, but really what you should see is that the green line, that's carbon dioxide. That's not favored very much. The black line is kind of favored. That's carbonate, but it becomes less favored the more acidic we get. And what's mostly favored is the hydrogen carbonate. All right. So here's another way of thinking about this graph. We have carbon dioxide that's in the atmosphere. Through wave action and adsorption, we get carbon dioxide that becomes dissolved carbon dioxide. It almost immediately reacts to form carbonic acid in oceanic environments, and then dissociates almost immediately after that into hydrogen ion, making it more acidic in the ocean, and hydrogen carbonate or bicarbonate. That's where we're at right now with our pHs. Where we used to be, though, was where we went all the way to the carbonate ion being favored, and it was much easier for shells to form. Here is a very short video that shows the dissolution of one particular organism's seashell as the oceans change in pH and become more acidic. All right, you guys, for your assignment today, you are to take notes on this PowerPoint slide and the videos you watched. Take a picture and upload that. And that's your assignment for today. Tomorrow you will do another assignment on acidification and carbonic acid so that you can kind of connect the ideas that we were talking about today with understanding them a little bit more fully. We'll have a Zoom on Wednesday. Then you have another work day on the 17th along with a little assignment. And the 18th is when your final interview is due. All right. I hope you have a great day, and I'll see y'all on Wednesday in the Zoom or in person on Tuesday. Thanks.